In the first few problems of 6.2.1 homework, we are asked to find the product of matrix A times matrix B and matrix B times A, if possible. So the first thing I'm going to do is even check to see if it's possible. Again, we do that by taking the dimensions and seeing if the internal dimensions agree. So matrix A is a 1 row by 2 column, and matrix B is a 2 row by 2 column. So this one, AB, should work since those internal dimensions agree. But if we go the other way, if we do B times A, it'll be a 2 by 2 times a 1 by 2. So that does not work. So BA will not work there. I'm going to go through the other three here and just verify that all of these will or will not work. So here A is a 1 by 2, and B is a 2 by 3, so that should work. And if we go the other way around, 2 by 3 and a 1 by 2, that will not work. So AB again works here, BA does not. This is a 3 by 1 and a 2 by 3, so AB will not work there, but BA should, because it'll be a 2 by 3 times a 3 by 1. In number 7, we have a 2 by 2 for A, and then a 2 by 3 for B, so AB will work. BA would be a 2 by 3 times a 2 by 2, so again, that will not work. Okay, so we know what we're going to do. I'm going to take these over individually to the right side of this here and start working through them. So we said AB will work for number 1, so for number 1 we will have 8, 1 times 3, negative 7, negative 5, 2. Okay, so remember it's rows to columns. Kind of hard to show that just through the screen, but we will do the best we can here. So it is the 8 with the 3 and the 1 with the negative 5. So 8 times 3 is 24. I'll write it out as 8 times 3. 8 times 3, and we'll add that to 1 times negative 5. So that's the first row to the first column, and then we go the first row to the second column. So that is 8 to 7, and 1 times negative 2. I think that 7 was negative. Yeah, that 7 was negative. So we should end up with a 1 by 2 answer matrix, and it looks like we've got that, a 1 by 2. So 8 times 3 is 24. That's negative 5. This is negative 56. And this is positive 2. Forgot the plus in there, plus 2. So we should end up with 19 and negative 54. For number 3, we said as well A and B would work together, but BA will not. So A is 3, negative 5, and B is 4, 0, negative 2, 1, negative 3, 2. Okay, so this should produce us a 1 by 3 matrix when those internal dimensions go away. So it should be a 1 by 3. So again, just a 1 row matrix. So we take rows to columns. So the 3 goes to the 4 and the 5 goes with the 1. So we have 3 times 4 plus negative 5 times 1. And then we go first row, second column. So 3 goes to 0. And negative 5 goes to negative 3. And finally we go last row, last column. So we have 3 times negative 2 and negative 5 times 2. Okay, so we end up with, that's 12 and negative 5. That is 0 and positive 15. And that is negative 6, and that is negative 10. So that'll be 7, 15, negative 16. Number 5, we said it was BA that worked at this time, so we've got B, which is 6, 0, negative 1, negative 4, 9, 8, and then 2, 5, negative 6 is A. Okay, so looking at the dimensions, this should be a 2 by 1 for our answer. So a single column 2 by 1 matrix. All right, so we're going to take the first row to the first column. So 6 goes to 2, 0 goes to 5, negative 1 goes to negative 6. So I'm going to give a little more space there. We have 6 times 2 plus 0 times 5 plus negative 1 times negative 6. And then we do the same thing with the second row here. So the 4 and the 2, the 9 and the 5, the 8 and the 6. Negative 4 times 2 plus 9 times 5 plus 8 times negative 6. Okay, so that is 12 plus 0 plus 6 for a total of 18. Then we have negative 8, positive 45, and negative 48. So that is going to give us negative 11. All right, and the last one from this section, we have number 7. So 7, I think, was back to AB. Yeah, AB. So we have 3, 4, negative 7, 1 times 5, 2, negative 8, 6, 0, 9, negative 6, 0, 9. Okay. This is A to B. So we go rows to columns. We'll go the 3 to the 5 and the 4 to the 6. So 3 times 5 plus 4 times negative 6. First row to the second column. So we have 3 times 2 and 4 times 0. And then we go to the last column. So we have 3 times negative 8. It doesn't matter, one of them's negative, plus 4 times 9. And then we move down to the second row and do the same process. So we have the 7 and the 5, negative 7 times 5, plus 1 times negative 6. And then we do that to the second row, so it's going to be negative 7 times 2, plus 1 times 0. And then in the final row, we have negative 7 times negative 8, plus 1 times 9. And so that's going to be 15 plus negative 24, 6 plus 0, negative 24 plus 36, negative 35 plus negative 6, negative 14 plus 0, and 56 plus 9. Okay, so let's add all this up. That's going to give us negative 9, positive 6, positive 12, negative 41, negative 14, and 65. Okay, so there is the first set. On to the second set, we have now to determine whether or not these matrices are inverses. So the way we do that is we multiply either AB or BA, it does not make a difference, and we want to get the identity matrix. So for these, they're all 2 by 2. The identity matrix we are looking for is 1, 0, 0, 1. So if we get that, we should be good to go. So for this first one here, I'm going to start back up at the top. So number 19, we will have 12, negative 7, negative 5, 3. I'm going to multiply that with 3, 7, 5, 12. So after seeing the second part of this lesson, this does look like it would be in the right ballpark, but we still want to verify this with multiplication here because it might not be. So we take that product, we get 12 times 3 plus negative 7 times 5. And then we do the same thing here. So we have 12 times 7 and negative 7 times 12. Well, that's definitely a 0 right there. Down in the bottom, we've got negative 5 times 3 plus 3 times 5, again another 0. And then we finally have 12 times 7, 12, negative 5 times 7, there we go, and 3 times 12. Okay, there we go. So this is going to be 36 and negative 35, so that together should make positive 1. We said that's going to be 0 because these are the same numbers. That one's negative, so the second half is negative. Same situation down here. And then we've got negative 35 and positive 36 like we had in the first one, so we get a 1. Yes, these are inverses. A and B are inverses. There we go. Okay, so for 21, we'll do the exact same process. So we have negative 5, 3, 6, negative 4. And then we've got 4, 3, 6, 5. So looking at this does not kind of fit the same pattern that the first one did. Again, if you've hopefully gone through the second part of this lesson, it doesn't quite fit that pattern. So this one, there's a lot higher chance that it's not going to be an inverse. But let's take a look. So we do rows to columns, and we've got negative 5 times 4 and 3 times 6. Right away, I know that this is not going to be the identity matrix because this is negative 20 and this is positive 18, which is going to give us negative 2. So that's not a good sign to start. We want a 1 there, but we'll keep going. The next one is going to be a 0. We have negative 5 times 3 and 3 times 5. So that's definitely a 0 there. And then we do the same thing here. So that is 6 times 4 and 4 times negative 4 times 6, which is another 0. So that's good. So we do have zeros, but we will again get another negative 2 here. So this is not the identity matrix. So these are not inverses. Okay. Even though it's the right look of it, it's negative 2 and negative 2. So they're not actually inverses because they are off by a factor of negative 2. So we can't do anything else with it. It'd be nice if we could factor and call it an inverse then, but we can't. If it does not produce the 1, 0, 0, 1, 2 by 2 identity matrix right away, then it is not an identity. Even if we can do some other row ops on it, it is not an identity. Okay. This one, on the other hand, we are looking to copy that correctly. Yeah, so we are kind of in the same boat here, where they switched the two that were on that diagonal, these two here, and made them negative, which is not exactly what makes an inverse. So we are probably going to be close again, but not quite. So let's take a look at it. We've got 9 times negative 1 plus 2 times 5, so we're off to a better start. And then we've got 9 times 2 and 2 times negative 9. Okay, so far so good. And then we've got 5 times negative 1, and then 1 times 5. And then we've got 5 times 2. We actually might be in good shape here. Plus 1 times negative 9. Okay, so negative 9, positive 10, that's good. We've got 18 and negative 18. We've got negative 5 and 5. And then we've got 10 and negative 9. Okay, so this one doesn't quite fit the pattern, but it still works out for us. We do end up with 1, 0, 0, 1. So A and B are inverses here. And even though it didn't fit the pattern, it still gave us the inverse property. So There are other ways to get inverses, and we've got one here that doesn't quite fit the pattern, but it gives us an inverse. Okay, so we've got one more here on this homework, number 25. So we've got 2, -3, -3, 4, multiplying -4, -3, -3, -2. Okay, so this one, there's a chance. Let's see what happens with the first set of multiplication here. So we've got 2 times -4 and -3 times 3. So we're off to a good start because that's going to be -8 plus +9, which will give us the 1 we need. Okay, we have then 2 times -3 and -3 times -2. We'll have -3 times -4 and 4 times -3, so we should get zeros out of both of those. And then finally we've got -3 times -3 and 4 times -2. Okay, so let's go through all this. That is -6, that is +6, that is a 0, that is +12, that is -12, that's a 1, which is a 0, and then we've got +9 and -8, so that is a 1. So for the final problem here, yes, A and B are inverses. So the only one that wasn't there was number 21. Okay, so that is it for this homework. Again, to determine if things are inverses, we've got this method where if they give us two matrices, we can multiply them together and check to see if we get the identity matrix, the 2 by 2 identity matrix. We will then be able to determine and find A inverse just given one matrix using a determinant method, which was the second part of this section. And then we go all the way back to the first part, which was just multiplying matrices together. We've now practiced that in every single one of those problems using that same skill. So the essential skill here is multiplying matrices. So we need to make sure that we're doing that correctly, taking rows of the first to columns of the second, and they have to have the same internal dimensions to be able to do that multiplication in the first place.